Okay, here we're looking to do something that's in 3 dimensions. So we're going to look at a cube, and we're going to try to find out what the angle is between the diagonals of the cube. In this case, by diagonals of the cube, what I really mean is the diagonals of the faces of the cube. So I went ahead on this here, and I grabbed a diagram from something offline, and then I superimposed onto it these axes. So if these are the x and y and z axes, then this point that I'm drawing right here, we would want to think of as being 1, 0, 0. I'm just arbitrarily making a unit length for my cube. And then this point here, we would want to think about as being 0, 1, 0. So you've got the x and the y and the z coordinates. So you might guess this point up here, we want to be 0, 0, 1. Then this point that's down here on the xy plane is going to need to be 1, 1, 0. This one that's over here in the xz plane needs to be 1, 0, 1. And this one that's over here in the yz plane needs to be 0, 1, 1. Finally, this point out here at the corner is going to be 1, 1, 1. All right? Now, I've got this, this angle we're talking about here, where 2 diagonals meet. And we're going to give names to the points that are involved there. Maybe we'll refer to this one as A, and this one as B, and this one as C. All right? So this means we're trying to figure out angle B, a lot like what we did with the triangles problem. But to get there, we need to figure out the BA vector and the BC vector. So your BA vector needs to go from this 1, 1, 1 over here to the 0, 0, 1. And that means that we're going to have to go -1, but not change our z-coordinate. Then we're going to figure out this BC here, which needs to leave the x value unchanged, but it needs to make both the y and the z coordinates go down by 1. Right? So when we write down the cosine of b here, we're going to put the dot product of those two things on top. The dot product will get you a 0 plus 1 plus 0, because when you multiply by 0, you get 0. And then for the magnitudes, we're going to have a square root of 1 squared plus 1 squared, and then the same thing again. I guess I should write a plus 0 squared on that, but, you know. So that means that the cosine of angle B is going to be 1/2, and that means it's a special angle. This angle B is going to turn out to be 60 degrees. And the reason that that's kind of interesting is that if we take a look here at a cube and put inside of the cube along its diagonals here these lines, we can actually make a tetrahedron which is embedded inside of a cube. That's just kind of a neat little geometric oddity.